So how can you tell one element from another? Elements differ from each other by the number of protons in their center or nucleus. Carbon always will have 6 protons, and oxygen is always going to have 8 protons. The periodic table makes this really easy to determine. If you look at your periodic table, you'll notice a number above each element. That number is called the atomic number. This tells you how many protons are in each element. This is also known as the Z number in chemistry. So let's go ahead and label everything in this element block here. We have the atomic number, Z, which tells you the number of protons, the element symbol, which you should already know, the element name, and the atomic mass, which we will talk about in a bit. So, using your periodic table, if I asked you how many protons are in nitrogen, you would tell me 7 protons because of the atomic number. So, how many in calcium? That would be 20. How many in chlorine? That's 17. So since the protons and the neutrons are found in the nucleus of the atom, they are called nucleoids. But if you add the protons and the neutrons together, you get something what we call the atom's mass number. The mass number is the sum of all the protons plus all the neutrons in the nucleus of the atom. So protons plus neutrons equals the mass number. Now remember, the mass number is not the same as the atomic number. The atomic number is the number of protons, and that can be found on the periodic table. The mass number is the sum of all the protons plus the neutrons in the nucleus of the atom, but it is not found on the periodic table. You have to calculate this number. So, how do you find the number of neutrons? Well, most elements have the same number of neutrons as they do protons. A normal carbon atom has 6 protons and 6 neutrons. However, many of the atoms do not have that same ratio. Why is that important? Well, sometimes you have elements with extra neutrons, or sometimes you have elements with fewer neutrons than the number of protons. Atoms like this we call isotopes. And isotopes sometimes have a tendency to be a bit radioactive. So there are 2 ways to write isotopes. So let's look at the first one with an example. Dinosaur bones, or let's say radioactive dating of things like dinosaur bones, is done by measuring the amount of carbon-14 left in the bone. One way to write an element's isotope form is to write the name of the element with the mass number after it. So if you have carbon-14, you have the name of the element and the mass number after it. So let's look at carbon-14. We know the mass number is 14. That means protons plus neutrons equals 14. We also know that carbon, according to its atomic number, has 6 protons. That part never changes. So what's the count in the nucleus if carbon is written in the form carbon-14? Well, carbon-14 would equal 6 protons and 8 neutrons. So it has extra neutrons in the center of the atom. This is why it's called an isotope. So what is in the nucleus for the element calcium-48? We know calcium has 20 protons because that's calcium's atomic number. We also know the mass number is 48, so 48 minus 20 will give you the number of neutrons. And 48 minus 20 is 28 neutrons. In some chemistry books, you will see an element written with numbers like this. This is the second way to write an isotope. The 17 on top is the mass number, and the 6 on the bottom is the atomic number, or the number of protons. So when asked how many neutrons are in this element, how do you solve this? Well, you just set it up like a simple subtraction problem. 17 minus 6 will give you 11 neutrons. Now let's talk about the number at the bottom of the element block, the average atomic mass. We know that mass basically means how much does it weigh. Protons have a particular weight, and so do neutrons and even electrons. So does the 15.999 on one atom of oxygen mean that it weighs 15.999 atomic mass units? Well, not exactly. First of all, let's get one thing straight in your mind. In nature, every element normally consists of 3 or more isotopes. Every element. In fact, oxygen has 16 different isotopes. So the mass at the bottom of the element box means it takes into account the mass of all the different isotopes plus how many of each one you have. That how many of each one you have is called the isotope's relative abundance. This means that one isotope can be 70% of your sample, while another isotope can be 30% of your sample. So here is what it would look like if we had an imaginary element with only 2 isotopes. We would set this up like a math problem. We have the mass of isotope number 1 times the abundance of isotope number 1, and that's in percent. That's going to equal the mass. Then we would take the mass of isotope number 2 times the abundance of isotope number 2 in percent, and that would equal the mass. Then what you do is you just add the masses together and you have the average atomic mass. So let's try a sample problem together. Element X has 2 natural isotopes. One has a mass of 10.012 atomic mass units and a relative abundance of 19.91%. The other isotope has a mass of 11.009 atomic mass units and a relative abundance of 80.09%. So let's calculate the mass of the atom. So solve this in your notes. The mass of isotope number 1 times the abundance of isotope number 1 in percentage. So we know the mass of number 1 is 10.012 atomic mass units times the abundance of 19.91. However, you cannot use the percentage in this equation. We need to convert it into decimal form. So how do we do that? Well, you divide that number by 100. So it comes out as 19.91 divided by 100 will give you 0.1991. So now we can use that 0.1991, put that as the abundance of the isotope, and let's multiply it by the mass 10.012. You multiply them out and you get 1.993 atomic mass units. So let's do this to the other isotope. We know the mass is 11.009 atomic mass units times the abundance of 80.09. Again, we can't use the percentage in this equation, so we need to convert it into a decimal form. So divide 80.09 by 100 and you get a decimal point, which is basically 0.8009. So we take the 11.009 atomic mass units times 0.8009, you multiply them out and you get 8.817 atomic mass units. So now all we do is add the 8.817 atomic mass units and the 1.993 atomic mass units, and you get the average atomic mass of our element X, which is 10.81. So you can see the average mass is a combination of the 80% of one isotope and 20% of the other one. You got it? So we're going to work more problems like this in class and also solve some more isotope problems. All right, we'll see you in class.